Hello.
Hello.
How's everybody doing?
Good.
Yes, Lisa, you all right?
She's eating noodles.
Noodles? Yes, Lisa, you never sent me those things.
I don't think she can hear you.
Looks like she's about to type.
Yeah.
Have you guys noticed that we all look like way more tired than we did like 2 weeks ago?
Yeah, it's getting really boring.
Like if you look at pictures of us, we just look so different. Yes, Lisa, you're good. You can send them to me today. We were actually ahead of they weren't totally due.
What is she doing with her eye?
Who's this?
Oh. I think Tamisha's here. Candace is here. Saran.
Next week we have April break. I'm gonna do private small group stuff, like 3 or 4 people. I'll put the signups on our Wednesday class.
Okay.
I figure that'll make it that'll make it good for people who want extra help. People may just want to take the break too. You guys can choose, but we'll be a little smaller.
Okay.
Trying to think what else is happening. So I put the work together today. We're gonna do implicit. We're gonna do related rates, and then every single day we do anything, we're always gonna do some fundamental theorem because that's just what we're always gonna do. And I know that some people are starting to. It's a little stressful. Like you might know someone who's sick. So if you're not here, I'm just gonna assume that people have the best intentions and you're dealing with some stuff because I heard a couple people are dealing with some pretty tough situations right now. So you guys are all here. I'm glad you guys are safe, but some people are dealing with some pretty tough stuff.
The numbers are getting real.
Yeah, the numbers are getting really scary.
Mm-hmm.
So definitely should stay in. Is it windy where you guys are?
Yeah.
No, it was boring though.
It's like crazy windy.
Outside.
It's not looking good outside.
It's not. It's not. Did anybody have a nice Easter if you celebrate Easter?
I don't.
You don't? Praise, you're smiling. Praise, did you have a nice Easter?
I guess I didn't do anything. My mother cooked, but that was it.
Yeah. Candace, did you do anything?
No.
It was a sad Easter.
I did Good Friday though.
Good Friday. Saran, no video today.
But it was, oh God.
Is anyone here Catholic?
I'm not.
No one?
Nope.
So I was the only one that had to turn into a pescatarian on Friday?
That's fish only.
I think Tamisha, because in Haiti we only eat fish.
That's what a pescatarian is.
Yeah.
I know, but we don't celebrate in my house, so.
Isn't it supposed to be fish the whole time? The whole 40 days?
It is supposed to be 40 days. Some people just do it on Good Friday.
Yeah, I thought it's supposed to be all the Fridays of Lent.
All the Fridays of a
Lent.
month and a half.
Month and a half Lent.
But I only do it Good Friday.
Oh.
Not eating meat for a whole day.
It's not bad.
I don't know how Saina does it.
Yeah, send it for a lifetime. Rhonda, can you text Rudolph and tell him to send me the problems too? I have everybody else's. Waiting for the thumbs up, Rhonda. Is Rhonda even there? Some people just like put their things and walk away and wonder. All right.
That's what I do in this class. I put it on and then just go sit on my phone.
Oh my God. I'm going to type in the chat. Hold on real quick. And we'll get started with these problems. So I posted these. The AP test is less than a month.
Yeah.
I know, it's crazy. Where's Johnny? He's usually not missing.
I have a couple of friends that go to Mission in the Hill
Yeah.
and Somerville High School. They're
Yeah.
also taking AP Calc. So what we're doing is that from May 1st all the way up to the exam, we're gonna just review.
No, that's a great idea.
Yeah.
That's a great idea. You know, you could also do it with your friends here, Saina, instead of just, choosing those friends over us.
I'm not. They came up with the idea though. Oh, come on, it's like a countdown. Like every day we do.
Praise, Candace, Yesley, Tamisha, Saran. You guys should form a group study. Rhonda, you too. The 6 of you alone.
I'm left out.
No, you have your new friends. It's cool.
No, they're always okay. I'm just gonna bomb your meeting and just work with you.
New friends are, of course, better. Not your day one friends.
We've been friends since 9th grade, the summer program. All right. Let me stop.
All right, everyone's got their paper ready?
I've known Candace since 9th grade. I just realized that. Yeah.
All right. So let's do some implicit, guys. Who's excited? I am.
Yay.
Yay.
All right. So
We're only supposed to find an M for A, right?
what do you guys think? Is it M or is it the slope of the line tangent or is it the equation?
Like, we're supposed to do the equation, but we have to find M.
You have to find M, but they give you pretty much everything you need, right?
Just plug in and plug him.
Yeah. So you need X, you need Y, you need M. But Yaslis in our last class was great. She said M is dy dx, which is one of the most important things of calculus, is understanding that. And they give you X, they give you Y, and they give you the formula for dy dx, aka.
Yeah.
So go ahead and work through that. And I think the more you guys can do this, actually doing them when we do these things, the better, because it'll kind of imprint into you guys a little bit how to do this at home, continuing to do that at home. I think that day of the AP test too, we'll probably meet up around like 11, because the test starts at 2, and we can just be in a group that whole like 2 hours, and we can like I'll just do like a shared screen. We can just hang out, like come and go, like have it on the background, and then when the class actually starts, it can be like when the test actually starts, we can shut the hang off. You guys can focus on the one thing. Lunice is in the house. Lunice, your problems were great. Lunice, your problems were really good. The ones that you did for the test, they were good. There's a lot of good stuff. Praise, you had some good answers. Candace had some really good answers. Walensky, Saran, you guys are doing good. Saina, Tamisha, a lot of really good answers. Did anybody get the values here? So X was -1, right?
Mm-hmm.
Yeah.
Y was 1. What did you actually get for your M?
1/4.
1/4 is correct. So y minus 1 equals 1/4 x plus 1, right? And that's your tangent line. You can leave the 1 on the right side. We're done. We're good. We got a couple points. All right. Part 2 is a little bit trickier. It says vertical. All right. So the bottom, great.
Yeah,
Saina,
bottom.
fantastic. The bottom of the function being equal to 0. But something weird happens here.
I have an X and a Y.
You have an X and a Y. So you literally have to go back to algebra 1 and do like substitution. Because what we can do is we can say, well, 3y squared equals X, right? Does that make sense? And if you have this, then you can just substitute 3y squared into X in another equation if you had another equation with X and Y in it. Do we have another equation with X and Y in it?
The original one?
We have the original one that has X and Y in it, right? So we can use the original. This is part B. We could say y cubed minus X times Y equals 2. But instead of writing the X there,
3y
I'm
squared.
going to write 3y squared there. Then I'm going to have 3y squared cubed minus, well, this y and this y will be another y, will be y cubed.
Yeah.
So minus 3y cubed equals 2. So then I get negative 2y cubed equals 2. Y cubed equals negative 1. Y equals negative 1.
Yeah.
I've got my y value. This is literally like a throwback to ninth grade. I've got my y. Now what do you got to do?
Well,
Take that
your
number,
x.
find your
1.
x.
Yeah.
That makes sense. So you could go into this equation, go back to that equation, and go y. So negative 1 cubed minus x times negative 1 equals 2. Get negative 1 plus x equals 2. X equals 3. That's the coordinate. So that's the point where we have a vertical tangent.
I kind of like, once I saw that I had a y and a x, I just equal to 0. I just froze. I didn't know what to do.
Okay. But you kind of get it now, right?
Yeah.
Good. Good. And that's, that's not going to always be there. But let's go look at C. And C was the one from last week. I remember Yasilis and Praise, you guys were like screaming. You were like, oh my God, we have to do this. Oh my God, life is so hard. Why do we have to do a second derivative and put it back in and do it 2 times? Oh my
We
God.
were just taken off guard for a second, okay?
But
Yes,
okay,
we're
good.
adding to the conversation.
Yeah.
You were adding to the flavor of the class. Like, yeah.
Yes.
All right. Well, you got to find the second derivative. So get used to it, because I actually think this could be on a test, because the reason why I think this might be on the test is a lot of work, but it's a lot of complicated work without a calculator. It kind of feels natural without a calculator. And it's notation based. So you could, if someone was trying to cheat, this is a place to kind of get caught a little bit. So I wouldn't be surprised if you see one of these problems on the test. So, all right. Quotient rule, right?
Yeah.
What's the derivative of the top?
dy dx.
Dx.
dy dx. Fantastic. Dy dx. Times the bottom. Minus.
Y. Isn't it y for the top?
Y times.
Y times.
3y dy dx.
3y. No, 6y.
6y.
Y dx minus 1.
Minus 1.
Perfect. Divided by
3y squared minus x squared. The whole thing squared.
good. Now here's the thing, and this is, hold on, I don't know if Yasilis and Praise, if you want a recap of last week. Oh my God, why do we have to do this? That's Praise's voice.
Oh my God.
No, my God,
No,
this is
it
so much
wasn't.
work.
Whatever.
Oh my God, whatever.
It is so much work. Why
This
can't it
is
just be a
like
regular
so much.
derivative?
So, but here's the thing, and this is why this is like the glass full people versus the glass empty. You're like, what? But look where they give you it. They give you the answer. It goes right there. And actually, if instead of being so negative about our lives and our situations, instead, if we look at it, we'll see that it cancels out. Yes. Hold on. Yep. That's the thing. Yep.
Not be negative.
Do you see that in this first one? Look what happens. Cancels out, right?
Yeah.
Do you see that? 3y squared minus x, 3y squared and x minus x on the bottom. So what's going to happen? What are you going to be left with?
Y.
Just
Y.
y. Very good. So we're going to be, that top left corner is going to be just y.
I thought I got that wrong.
And then the next one is basically, you got this y, right? So you got a minus sign. You got two of these y's now.
Ow.
You got another y. So how many y's do we have total?
3.
So we got 3. So y cubed. We've got a 6, right? And And then we've got negative y times this negative 1, which is sort of by itself. So plus y.
Over.
And then we could add like terms to be 2y.
Mm-hmm.
And then we can just plug in and we're good, right?
Yeah, I left it in the brackets.
Left it in the brackets. You could have even plugged it in earlier if you wanted. You can simplify as much as you can, and you're good to go. All right. How do we feel about that problem?
Better, no?
Better. And if you had a couple examples and you have your notes, and this is where you should maybe write down, implicit and kind of categorize these things. Some people like being really organized. Some people don't. They like the sort of the controlled chaos. So, but if you want to have a couple implicits, that's why I put the title a little bit bigger. I made the font a little bigger. Like, hey, we did a couple of implicit examples. And, I don't know what your workspaces are, if you have desks or if you're doing these things like on the couch or something like that. But if you want to say, hey, this is my implicit stuff and kind of maybe put it in a paper clip or something like that, or organize it in a notebook, could be a good thing. All right. This one's kind of cool. And I wouldn't be surprised if we see something like this.
Yeah.
It's got a second derivative of implicit, and then it's got a differential equation. It's got a particular solution. So this one's got two of the longer topics. So let's do A together. Someone tell me what I should do first.
Rewrite it.
I should rewrite it. Perfect. Very good. Where'd you guys go? Did you guys see the article about Harvard or BU, Boston University?
No, what?
That they may not go until January?
Oh, yeah, they cancel classes. I heard in New York they did that too.
Till January?
For the rest of the year, they canceled school.
No, January. Like
Okay.
Like not going to school in September.
Tuh.
Like, what is that going to mean? All right. So what type of rule do we got for this one?
We have a product rule.
Product rule. So derivative of the first.
It's still implicit. So
dy. Oh, wait. 2y dy dx.
Yeah, you got it.
times the second.
Times the second. And now it's plus. Remember, product rule is plus.
Y
squared.
Y squared.
Times
-2.
Negative
2. Good, perfect. So you got it, and then this is the part that apparently, according to Praise and Yasley's last week, was so hard. Just that part. So much work.
Today's just your day, isn't it?
No, I'm really going with this, huh? 2y. What goes there?
Oh, y squared 6 minus 2x.
Y squared 6 minus 2x. We just put it right back in there. And this is a point right here. It was actually 2 points. We've gotten 2 points for the derivative. They're going to give us a third point for the actual number. And I would just plug in, although I will say this, you're plugging in x equals 3.
Oh.
Sorry.
Whose dog?
That was me.
That's your dog?
No, that
No,
was me. That was a hic. You know what? Forget it.
Y is 1/4.
Y is 1/4. And I think we might have actually done this particular solution problem before.
You can just
We
plug it.
plugged in. Yeah, we can just plug in. We plug it into all this stuff and we're good. All right?
Yeah.
All right, what about B? B's not implicit. Let's think on our toes here. What do we got to do?
Okay.
Write it and then move things around.
Split it. Yep, you got it. Move things around. I even like that better. I might call it that from now on. Move things around. So this becomes dy over y squared. 6 minus 2x
Yeah.
dx. You got a point. Whoop, whoop.
Process.
Oh shoot! I forgot to do this. Hold up.
Now what?
It'll be 1 over y. I just memorized that one.
Yeah, you're memorizing it, right? How many times has it been this? It's been this so many times. It's negative 1 over y, right?
Yeah.
Equals
6x minus x squared plus c.
We all concur? Do we all agree? Lunice, praise, you guys agree? Saran, you agree? Cool, thumbs up, yep. And then what are our values? We have 1/4. So the 1/4 is there, and x is 3, so we get negative 4.
Equals, then we have 6 times, we got 18 minus 9 plus c. C is equal to negative 13.
You got it.
I want to make potatoes.
Potatoes?
For eating. Do you still want?
Actually debating because you take an hour and I get hungry.
You just ate noodles.
Mommy might end up giving you the rest of her noodles too. She didn't finish. She said she might not finish it. That's a big plate that you gave her. I don't know, Mommy.
She complains. Okay, shoot.
Why?
Noodle. Wait, hold on. Is it your sister?
Yes.
You guys are talking about you're doing noodles, and we're doing noodles and potatoes. Nice.
No.
A lot of carbs.
Calculus.
I don't know what this is.
Calculus. What's our final equation? Take us home.
Minus negative 1 over 6x minus 2x minus x squared minus 13 equal to y.
You got it.
Compadre, espérate.
All right, 1 page done. Questions?
It took up 2 pages for me.
Yeah, I'm about to be on my 3rd.
Sorry. Praise said it like I should feel guilty. Yeah.
I'm sorry.
You're
About to
paying
be
for
on
my
my
paper.
3rd, you know, it's just. Candace, you getting all this stuff?
Yes.
Cool, nice. Candace is, you guys have perfect attendance. Candace is one of those perfect attendance. Perfect attendance.
Okay.
Praise, you're at the one day.
Yeah, I think, yeah.
All right. Whoa, what do we got here?
Wait, are we getting a formula sheet? Because I don't know.
I'm gonna create my own if they don't.
They'll give it to you in the problem. Like if you look at it here, it has it.
I'll add some extra things to my formula sheet before the test starts.
They'll give you a formula sheet in the problem. They actually, well, the one that we're gonna look at next on the next page, it's actually kind of cool what they do. You'll see some. It's kind of wild. It's a crazy formula. All right, hold on. Are we ready?
Yeah. I'm gonna try to draw this.
Draw it. Yeah, that's
right.
what I'm doing.
Well, okay, you can try to draw it.
Oh yeah, let me draw.
I failed that completely, but it's fine.
We are adding.
So what do we got going on here? We got a basically we got water in a barrel. We got water in a can. One of the things with these, reading carefully is the key to these problems. So I'll zoom in a little bit. So diameter 2 feet.
Yeah.
Rainwater. Rate of change. So when I see words like rate of change, I'm going to go ahead and I'm going to rate of change of H. So H is changing.
Mm-hmm.
And they give us
So that's DT.
The equation.
DH dt. All right. Related rates. Think about what related rates means. It's going to be one thing's changing, another thing's changing, everything's intertwined. All right. And then they give you the formula for that we're going to have to set up. Then they're going to ask you a question about it. And most of the time, I'd say 80% of the time, they're going to give you one of the rates, and they're going to ask for the other rate. And because they're connected, that's what you're going to have to do. And you're going to have to remember that this operates like implicit. Everything is, there's no X in this. Everything is like a Y. So if I take a derivative of H, it's dH dt. If I take a derivative of V, it's dV dt. If I take a derivative of R, it's dR dt. with the exception of the times when those things are constants. Those things are constants, then they're just constants. They don't have derivatives. Constants don't change. So if you look at A, you guys did your shape, cool. First of all, you have to read very carefully. What are they asking for?
Find the rate of change of the volume.
Right. So they're asking for the rate of change of the volume. What would we call that?
dv dt.
dV dt. Fantastic, Praise. So for A, first step, I'm going to write my formula that they just give me, which is my volume formula, which is pi r squared h. And it seems weird, but I actually just take a derivative of this. Now, here's where the tricky part is. Radius sometimes changes, sometimes it doesn't. In this case, when you have a barrel, does it change?
Oh.
Yeah, yeah, it does. A
No,
barrel?
it doesn't.
Yeah,
Rate-
a barrel is like,
No, it doesn't.
No, okay. Well, this type of barrel, I get what you're saying. With like the ones that, like, yes, you're right. If it was like a barrel, like Cracker Barrel, like the pickles,
The
and stuff like that.
cylinder.
yeah,
But this is a straight.
Mario.
Is it the same here as it is here as it is
Yes.
here? The radius is always 1 because the diameter is always 2. So the radius is actually a constant. Okay.
Yeah.
When we have a constant, we usually just move it out of the way, right?
Mm-hmm.
It doesn't go to 0, but it goes to the front, and we can kind of leave it there. We'll just kind of leave it there. Same thing with the pi. These are both constants. They can get left there. Those are constants. So now I'm going to take the derivative of this. What's the derivative of v? Well, it's implicit, so it's going to be dv dt. Like I said, these are constants. So you know how this r squared, you think bring down the 2? No. Stays. Derivative of h, though,
dH dt.
is dH dt. And that's what you got, right?
Hate this shit.
So that's the so this is now a point, okay? Now it's asking at a specific point when the height is 4. When the height is 4. So I'm going to go pi r squared. Now r is always 1, right?
Mm-hmm.
So 1 squared is 1. I mean, I could write it there, but it's not going to do anything, right? This is going to be, you can almost ignore that. Pi is there, though. dH dt, though, they give it to us. It's right up here. I'll highlight it for you. You see the dH dt up there?
Yes.
Negative 1/10 times the radical of h.
Which is why. Oh, yeah.
Negative 1/10
Mm.
radical h, but h is
4.
4. So what is,
2.
it's 2. 2/10. Someone said it. I think, was that you, Lanice, or Praise? Did you say it? Negative 1/5. Who said it?
Me.
Oh, I'm sorry. You got a lot going on your screen. It's a little hard. You got noodles and potatoes, and you got a sneezing dog. It's a lot.
And then my dog isn't even here with me. Okay.
So this is dV dt. Telephone. That's it. That's the answer.
Mm.
Yeah, right.
Okay.
Yep.
Everyone good with that? Not that bad. Really not that bad. These can be disguised as implicit problems. I want to show you something here. When the height of the water is 3 feet, so now we've got h is 3, is the rate of change of the height of the water with respect to time increasing or decreasing? Rate of change of the height. Okay.
What did they give you the rate of change?
But they're asking if the rate of change is increasing, right? So you have to find the derivative of that. Does that make sense?
1/10 stuff.
Yes, because dH dt is what you're asking about, right?
Yep.
Well, how do we know what this is what they're talking about? It's the rate. This is the rate of change.
Mm-hmm.
And they want to know if that's increasing or decreasing. So what we should do is we should take the derivative of that, but that's the second derivative.
Yeah.
So do you guys see this is just like implicit where you're going to have to reinsert it? The thing I was making fun of Praise and Yasley's for is going to happen here also. That makes sense? So I'm going to have negative, but it's actually not that bad. Negative 1/10. The derivative of a square root, you get 1/2 comes down.
Yep.
So I'm going to have the 1/2 will come down. So that's like the 2, like that, right? The radical comes down. But then I'm also multiplying it by dh dt. So if we think about that, it'll be -1/10. I'm rewriting it. 1/2, 1 over radical h times -1/10 times radical h on the top. Does anything happen here?
Cancel out.
Cancels out.
And the 10.
No, 10's
Oh, no,
multiplied.
it doesn't. Yeah.
Not
bad.
1 over
Positive.
10. Yeah, positive 1, yeah.
1 over 200, right?
Yeah.
Nothing to plug into. That's greater than 0. Therefore,
Wait, so what was so relevant about the 3?
it's kind of a trick. There's nothing to plug into it.
Because we don't have any H's, right?
Yep.
Oh, no.
And you notice we have another separation problem here.
Can you zoom out a bit, please?
Yeah, I'll just give it a sec. You guys want to try the separation one on your own?
Thank you.
Why don't you guys try the separation on your own? It's you're separating this, and t is 0 and h is 5. All right, so you're gonna split that. You're gonna antiderivative both sides of that.
Isn't it kind of like the particular problem?
Yeah, particular. It's the same thing. It's like those differential equations, particular solution ones. So I'll take a couple minutes to do those. I'm gonna get a glass of water, and why don't you guys try to see? Take about 5 minutes to do that.
What are we doing? Find the rate of change of the house at time known. Height of the water is 5. Use separate variables.
It was not.
Yeah, that would be. Motherfucker. Is a tree falling down? Gonna be
I put the full answer up. Let me know what you guys think. If there's any specific point where you'd like to have it be explained.
For the 2/3 of h, you just did the entire, right?
Yeah, so basically it was radical h on the bottom, and then I brought it up to be negative 1/2.
Mhm.
And then when I add 1 to that, I get positive 1/2.
Mhm.
And then when I flip the 1/2, I get the 2.
Yeah.
So that's why it's positive, and that's why it's 2.
All right.
And then the right side was pretty easy.
Yeah, it's nothing to change.
Yeah, just add the t and then the plus c. And then I plug in 0, and c's just by, you don't even have to do anything for c. It's just there. And then that last step, I divided by 2 first. So I got rid of the 2 on the h. I got rid of the 2 on the radical 5.
Yeah.
And then the 10 just became 20.
What are you doing?
And then finally, I took the square root of everything, but I put it in parentheses. That's important. You don't want to just square each term. You want to actually, because it's 2 things on the right side, you have to put in parentheses with a square. You can't square each thing because of like the way the like order of operations would work. Like I can't just do this. I'll show you. I can't do like that. That's not the way. You don't distribute powers like that. So I have to do like that to cancel out that. All right, so this is what you're finding.
Square.
But hopefully, you got some points there you're kind of seeing. I saw Praise kind of nodding along and saying, yeah, maybe there was an issue with the radical h and stuff like that. So that's something that you might want to look at and study a little bit.
I put h to the 1/2. I forgot it was negative 1/2. So.
Right. So just bring in those. And those are the things that practice makes perfect of. Any other questions before we move on? All right. This one is another related rates. It's only the part A we're doing. I took this from a calculator problem where there was no way to get the rest of it right. But one thing I want to point out here, they gave us a formula for volume that doesn't even have R in it. So they'll give you sometimes formulas that just work for the problem. Like they already converted the H to R. So that was what I was kind of talking about with some of these problems. So what rate is the volume changing. So they're looking for,
dv dt.
that's what this problem's asking for, right? You already got a picture. You already have your formula. And you got to find dH dt. Where's dH dt? They have to give you one of the rates. Where is it? Do we spot it anywhere?
Of
Is
t.
it H prime?
It's H prime, right? So it's this. Perfect. Perfect. Awesome. So take the derivative of everything and do it like implicit. Because all parts are connected. That's what implicit means. dv dt. This is a variable, it comes down. Basically cancels that out. Does that make sense? 3 coming down, cancel out the 1/3.
Yeah.
So 3 pi h squared dH dt. Very important that we include that. And then they have to give you some type of h or something. Time t equals 0, but that's not what we're talking about. At the height of the water of the tank at time t equals 0, the height of the I'm gonna
Is 25 meters.
you guys see that? So
Yeah.
you don't plug in, so h isn't 0, h is 25. Kind of threw that in there a little tricky. So now it's going to be 3 times pi 25 squared dH dt. You would just plug in your 25, so I'd do -2 minus 24 to the e negative 0. And this was a calculator question, like I said, so.
Is this R or T?
Oh, that's a good point. Yeah, so you plug in 0 into that one. Oh, that's cool. Oh, that's neat. That's nice, Ashley, seeing that. So it's 24 to the 0 is 20. So e to the 0 is 1, so 24 over 4. So it's basically this. That's good. You're plugging in 2 different values. Very good. Bravo. So that's 2 minus 6, so -4.
Yeah.
But actually, we can stop, right? We're good. All the numbers are gone. Zoom out a little bit.
All the letters are gone.
Mr. Desai,
Yep.
I'll just finish the video later. I have a meeting.
Okay.
All right.
All right, cool. We're actually almost done. We just got the FTC stuff to do. And
This say.
it's last page. I think we'll probably stop here on this one. All right. Why don't we go through this one actually pretty quick? We got to I just want to go through the text of this, right? Just to make sure you guys are always clear on what the FTC stuff is presented. So one thing I've been doing is I've been looking for problems where it's a little different, like it's not just the normal symbols. So the graph of a differentiable function f is shown above, blah, blah, blah. The graph f has horizontal tangent lines at these points. They actually give you the regions. So one thing here, see how it says 5, 4, 5, and 3? That means that this right here is 5. That means that this right here is 4, but actually it's -4 because it's below the axis.
Mhm.
This right here is also 5, and this right here is 3. Okay? So sometimes it's not geometric, but if they give you the numbers, it's just as much. And then this is the key phrase here. I'll put it in a different color. I'm going to use a pink or something, just so it stands out. let G be the antiderivative of F, such that G of 3 is equal to 7. So that causes a chain reaction in our minds right now. Ding, 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 ding. This is our big moment where we say, okay, 3. So this is where the fundamental theorem comes in. 3 to x f of t dt plus 7 is equal to g of x. All right, and this is by the fundamental theorem that we have this. All right, and why I put the plus 7 there is because that is all gained from right here. So this is the stuff that you want to really extract. This will give you tons of points on the test because it lets you answer the problem. If you don't set this up, you're not really in the right shape. So now we're looking at G prime. And this we can do our same thing is really equal to F, right? And this is by the fundamental theorem. G double prime is equal to F prime. We had to work a little bit harder for this than we did before. If you look at what this is asking, when does this have a relative maximum?
At 0? No. Wait a second. No, -2.
-2 is absolutely right. G of x has a relative max at x equals -2. Now, Praise, you're absolutely right. How come?
Because Journey, shut up. Because F prime is changing from positive.
G prime, you got to be careful.
G
Because we're
prime.
talking about G, right?
Oh, yeah.
But what were you about to say?
Because G prime changes from positive to negative.
Perfect.
I don't know if you know this, but G double prime equals F prime of X, not F.
Oh, yes. Sorry. Thank you. Ashley's is on point today. Very good. So we just did this one completely. Great. When is G concave up? Let's look at the graph.
From 1 to 1.
-1 to 1.
2 to 3.
Yes, very good. -1 to 1 and 2 to 3 because
G double prime is greater than 0.
fantastic. Fantastic. Awesome. So you got these two, and we did them really good.
Oh my god, it is like, it feels
Yeah.
like the world's gonna end.
I feel like Wizard of Oz. Like I feel like Dorothy.
I think a tree broke because while you were gone, it sounded like the world, it just sounded like a tree broke, like a mini tree.
The window in my kitchen keeps getting knocked on.
Wind is scary. There was one night that I thought my roof was going to literally
Every
blow
time
away.
I unmute myself, you always gotta bark.
What's your dog's name?
Coral.
Look at Candace. Jesus. Candace was just...
She's right behind the thing too.
I know, but just Candace is just laughing.
Yes.
Oh, man. Good
It's
times.
coral in English.
All right. I want to show you part C, because C I think will be on the test too. I think they'll definitely have L'Hopital's rule.
Of course.
But I want to show you how it's going to go down, all right? And what you need to write. Because actually, L'Hopital's rule wasn't even on the AP test until last year. It was the first year. It used to only be on like the harder AP tests. And this year, last year was the first year. So they had a lot of like trainings about how to do it the right way. So basically, they want you to plug in, but you kind of know what you're going to get. You're going to get 0 over 0. All right, but you need to show that you plugged in. So you actually need to basically write it again, and you need to evaluate it. Meaning, you need to plug in. All right, now this is what makes this problem specifically interesting. To do G, you actually have to find, so to find G of 0, you actually have to go 3 to 0 f of t dt plus 7. Now, this is specific to this problem. All the L'Hopital's rule problems, you're not going to have to necessarily do this. But this one has, they gave us, this is a fundamental theorem problem. Oftentimes, L'Hopital's rule won't be connected to the fundamental theorem. We learned L'Hopital's rule way before we learned the fundamental theorem. But in this case, to find the G, you had to know the fundamental theorem. So this is a great problem because it's kind of like what I was saying last week, where they're going to mix the content. They're going to mix things around. So let's look at the graph. Where do we start on this graph?
3.
We start at 3. So we got to go backwards, right?
Mm-hmm.
So we're going to 0. Is that where we're going?
Yep.
So we have 3 and 5 is -8. Is that, do you guys agree with that?
Yep. -3 plus -5.
And then we're going to add 7.
Yep. So then.
-1.
We're going to get -1. And that's actually what we want to get, because look, don't you want it? L'Hopital's rule is going to work if you get 0 over 0. And look, I'm going to have -1 plus 1 over 2 times 0. So I'm going to get 0 over 0. All right?
Mm-hmm.
So now you want to write that you're using L'Hopital's rule, but you really want to have, I'm going to highlight it. You want to have all this. Well, you want to have all of this for L'Hopital's rule every time. You want to have the values plugged in. You want to write the limit, and you want to have it equal to 0. So let me say that again. You want to write your limit. You want to plug into your limit, and you want to show that it's 0 over 0. Okay? In this specific case, we had a FTC. Whoa! Anytime you have FTC, you need to use the FTC. Okay? But that was just to find G. All right. Now what do? Is you actually write L'Hopital's rule. Just write it.
How about hospital?
Yeah, it's literally L with a hospital. L apostrophe hospital is how you spell it. There's 2 spellings. I guess I'm not really sure why there's 2 spellings. I guess there's a French spelling and a regular spelling and an English spelling. But one of them is hospital. So now L'Hopital's rule is you actually take the derivative of the top and the bottom. It's not a quotient rule. It's just the derivative of the top and the bottom. So we look back and we say, okay, G prime of X now. Does that make sense?
Yep.
The derivative of?
Over 2?
Over 2. Great. It's still a limit. Does that make sense?
Mm-hmm.
And this extra one went away because we took the derivative of 1, it goes away.
Yep.
Now, G prime is this.
G prime is 0.
And it happens to be 0, right?
Yep.
So 0 over 2 is just a regular thing. That's fine. That's the answer. We don't have to do anything crazy there. Zero's a fine answer. 0 over 2 is nothing weird. You only do L'Hopital's rule and you have 0 over 0. You should definitely copy what's on the screen now, especially, so I just want to say something again. I want to make sure this is clear. What's highlighted is just your process for L'Hopital's rule in yellow. What's highlighted in pink is the fact that they can throw a topic that you learn 5 months later into a problem like this is you learn L'Hopital's rule in October, you learn the fundamental theorem in February. They're mixing the 2, and that's cool. Expect that. They're going to do that a lot. All right. Any questions on that at all? Polinsky, Lunice, Saran, Rhonda, Misha, you guys are good?
Yeah, I'm good.
Good. Some days it's not a camera day. I feel you. I got my hood on today. I'm not. All right. We're gonna do part D. I think this part and these three questions. If you guys will do these, I'll post the answers tomorrow for a video. Does that sound good? So homework, and I will post the video answers. People complained last week because I did them too late. So by 4 p.m. All right, I'll post the video answers by 4 p.m. For these 3 problems. But right now, don't forget this one too. Right now, we're going to do part D. All right? And part D is going to take a little bit of time. Let's look at this. This is similar to one of the ones we had last week that was like G of, on the practice test, the one that was like integrating G of 2x plus 4 or something like that. Do you remember that problem?
Mm-hmm.
This is very similar. And Praise nailed it. She said it was U substitution. You were absolutely right. So let's do this one, and then that'll be it. You guys can go back to your days. Okay, so we're going to find the value of this. So, and this is what h of x is. So this is here essentially, right? So really what we're doing, if you guys follow along, -2 to 1, 3 f of x, sorry, f of 2x plus 1 plus 4, okay, dx. So this is what we're dealing with. Be prepared to be ready for this. This is going to be something that we have to do. First step, I'm going to take that 3 out.
Is it times?
And I'm also going to separate these into 2 integrals because that 4 is by itself. So I'm going to put the 3 there, f of 2x plus 1 dx, and then I'm going to have -2 to 1 for dx. Okay? I've got 2 things, and remember the 3 is not with the 4, so I don't want to get confused there. Then I'm going to look here, and I'm going to call this u. Does that make sense?
Yep.
So u is going to be 2x plus 1. Du should be 2. It's not there, so I'm going to divide by 2. I'm going to put that in a box. All right. So now I've got 3 over 2, -2 to 1, f u du, plus -2 to 1 for dx.
Wait, I'm lost. Why did you divide the 3 by 2?
Because I needed to get rid of this, like anti-chain.
Oh, okay.
All right. Now, this is the tricky thing, and so far I think it's actually pretty straightforward, but I want to tell you one thing. Do you see these limits right here?
Mm-hmm.
Those get adjusted by this. Does that make sense?
Yeah.
So like you'll actually plug in, and I'll kind of show you what I mean by that. Like this is -2, but this is an x, right? So that goes in here to be -4 plus 1. Because of this. I mean, we could also think of it as like plugging into that,
Yeah.
the antiderivative of that. Does that make sense? Or we could just leave it. One way or another, it has to adjust. Like, because what's really in here? 2x plus 1, right?
Yeah.
So when we plug in the 1, we're going to get 5. We're going to get 3, sorry. When we plug in x equals 1, we're going to get 3. When we plug in x equals -2, we're going to get -3. Does that make sense?
Mm-hmm.
So when we look at our graph, it's actually the entire graph, right? Because look where our graph starts. Starts at -3, goes to 3. Hopefully that clicks a little bit. Let me kind of restate it again. You get to this point, and you look at this function right here. As I take the antiderivative of it, the antiderivative of this is basically my graph, right? So if I took that's the area under the curve. That's that stacking, those stretching of those moments. So if I do this, I'm saying, okay, that's the antiderivative, right? But it still has this input that hasn't really been addressed yet. But all that's going to do is it's just going to change the x values of where I'm starting, what I'm plugging into, right? So if I think of this as the antiderivative, don't eat the cake, and then I put the 1 in there.
So
Well, the 1 there, I've got 2x plus 1. So when I plug in x equals 1, my upper limit isn't 1 anymore. It's really 3. And when I plug in the same thing with my lower limit, it's not -2 anymore. When I actually plug that in, it's -3. So this just changes what goes into my boxes, essentially, or where I end. So now that I'm integrating, I'm saying, all right, I'm starting here and I'm integrating all of these because I'm really starting -3. So that we said was 5, right? We agreed that that was 5 and
Yeah.
that this was -4 and this was 1. This was 5. This was 3. So this is positive 13 minus this 4. So the whole thing
It's
is
9.
9. I've still got that 3/2 in the front, right? But I've got that. I'm very aware that this concept is weird. Why did we not go from -2 to 1? The reason why we didn't go from -2 to 1 is because of this adjustment that we had to make. All right? We're not totally done yet either. This one is still this, right? We haven't dealt with this yet. Well, I want to go back to the very first day we did an integral. This is a straight line. If you think about this, 1, 2, -2, 1. The line y equals 4. What's the area of this box?
Mother.
This is 4. This is 3. What's the area of that box?
12.
12. So this is 12. So we've got 3/2 9 plus 12 is our answer. I know this class doesn't watch the replays quite as much as others, but you may want to watch the end part of this question, part D. Maybe watch it again. You get to look at yourselves on camera too, which is nice. And that's always fun. So I think I would look at part C and D of this to review, and then that'll remind you guys also to do this homework, and then do these 2 homeworks, and then watch my video. We'll have the answers. And you know what I'm going to do too? In the video, I'm gonna go over one of these problems again. I'll do the one from the practice test actually. Okay, and we'll talk about that one. That was the one like g of 2x plus 4, something like that. We'll go over that one, and then that'll kind of be until Wednesday. All right. Gasly, send me those problems by tonight. Okay, and then Rhonda, tell Rudolph to do the same.
Cool.
All right. I'm gonna post this video now for anybody who wants to watch it. It takes about 5 minutes to update.
Okay.
Stay safe.
Bye.
Bye. See you Wednesday, and watch my video tomorrow.